All right, number 8 through 11, we want to state the end behaviors using arrow notation. Arrow notation is as x goes to negative infinity and as x goes to positive infinity, then y goes to blank. So this is arrow notation, not just saying the arrows up and down. You have to write it like this. So we always look at the term with the highest degree. So let's determine which direction our arrows are going. If it's x to the 5th power, is it an even or odd exponent? Odd. So are they going to go in the same direction or opposite directions? Opposite. And if it's negative, positive and negative tells us what our right arrow does. So what's our right arrow going to do?
Go down.
It goes down. So that means our left arrow is going to do what? Go up. So negative infinity is talking about the left arrow. So is our left arrow going up to negative infinity or up to positive infinity? It's going up, but to positive infinity. And then the positive infinity one talks about the right arrow. And it's going down, so it'd be going down to negative infinity.
Wait, so the up arrow is for the negative?
So always it's going to start with these two. You're going to have an as x goes to negative infinity and as x goes to positive infinity. Our x-axis is this one. To the left side, this is our negative numbers, so the left is negative infinity. The right side is positive numbers, so positive infinity is talking about the right arrow. So you're always going to start with as x goes to negative infinity and as x goes to positive infinity. The negative infinity is talking about the left arrow. So this is going up to infinity. The right arrow is going down to negative infinity. All right, on the next page, we want to state the increasing values, decreasing values, and constant values from the given graph. Let's look at 13. So let's start by finding our increasing values. So just like how you read going from left to right, you read a graph going from left to right. If I was a person starting at the left side of our graph, would I be walking uphill or downhill? Uphill. So I'd be increasing. And increasing, decreasing, and constant, we always look at the x values. So we're only looking at the x's. So I start here. Let's pretend this is a closed circle. We start at,
-7, right?
yeah, -7 or -8. We can call it -7. So -7. And then this line stops at -3.
It's always in brackets.
All right, let's go to the next part. Here, would I be walking uphill or downhill? Downhill, so I'm decreasing from -3 to, where do I stop decreasing? What's the x value here? 0. Then from 0, I start increasing again. I walk uphill to what value?
To 1.
To 2. So we're increasing again from 0 to 2. And then we are constant. Let's say this has an arrow here, so it's going to infinity. We're constant from what to what? 2 to infinity. All right, next, let's do 16. So when we multiply, if we have a binomial raised to an exponent, we got to write it out that many times and multiply it together. So 3x plus 2 times 3x plus 2 times 3x plus 2. Bless you. We can't multiply all three of these together at once, so I'm going to start by multiplying two of them. So this would be 9x squared plus 6x plus 6x plus 4. So 9x squared plus 12x plus 4. Then we're going to multiply the third one to it. Just make sure everything in the first set gets multiplied to everything in the second. So 9x squared times 3x would be 27x to the third power plus 18x squared. 12x times 3x would be 36x squared. Plus 24x. Then plus 12x plus 8. Combine our like terms, 27x cubed. Then we have 18 plus 36 would be 54. Yeah. Plus 54x squared plus 36x plus 8. Next, we want to find the inverse of each function. Let's do 21. So to find the inverse, we switch our x and y, and then we solve for y. So we have to undo everything on the right side. So first I'm going to add 6. So x plus 6 is equal to 3y cubed. Then we can divide by 3. So x plus 6 over 3 is equal to y cubed. Then we want to take the cubed root to cancel out with the third power. So our inverse, which we could say y to the power of -1, that's just the naming of our inverse, is equal to the cubed root of x plus 6 over 3. Or we could see it written as f of x, or f -1 of x is equal to the cubed root of x plus 6 over 3. So this is just the naming of the inverse. So if it asks you to find f -1 of x, you know that it's asking you to find the inverse. All right, next we're going to simplify each expression. So I'm going to do, they're all kind of different. I'm going to do 23, 24, and 25. Actually, let's do, oh, there's two number 23s.
Do the first one. Because I already did the second one.
Well, what's the difference between the second one and the first one?
Oh, the negative.
The negative. So what do I have to do first in the second one? Distribute the negative. So they're essentially the same thing, and just when you're subtracting, you have to distribute the negative. We can do the first one, though. So we want to combine the real parts together. So 5 minus 4 would be 1. And then we combine our imaginary parts together. Negative 3i minus 7i is negative 10i.
So you don't multiply? Oh, okay.
Not when it says plus.
Duh.
So here we would, for this one, it'd be negative 7 and negative 4i. So negative 12 minus 7 would be negative 19. 8i minus 4i would be plus 4i. Oh, yeah, it should be minus. Let's do the multiplying one now. So here we have to FOIL. So we get 12 minus 18i plus 10i minus 15i squared. Does anybody remember what we do to an I squared?
Makes it negative.
It changes it to be -1. And what's negative 15 times -1? Positive 15.
Oh, wait. Oh, because it's already negative.
It's already negative. So then we combine our like terms. 12 plus 15 would be 27. And negative 18i plus 10i would be negative 8i. Let's look at 25. So whenever we're dividing by our imaginary numbers, we have to multiply by the conjugate of the denominator. So our conjugate is the same thing, but the sign in the middle changes. So instead of it being 1 minus 2i, it'd be 1 plus 2i.
We have to foil both.
We have to foil both. So let's start by foiling out the top. We get 2 plus 4i minus 3i minus 6i squared. Well, what do we do to I squared?
Makes it positive 6.
Changes it to positive 6. So 2 plus 6 would be 8. 4i minus 3i would be plus I. So 8 plus I on top. On the bottom, we FOIL it out too. So we get 1 plus 2i minus 2i minus 4i squared. So 2 i's cancel. What does the I squared change to?
Positive 4.
Makes it a positive 4. So 1 plus 4? 5. So our answer would be 8 plus I over 5. Let's look at 27. So here we have to find our least common denominator and multiply that times everything. So first let's factor out the x squared minus 9. What would x squared minus 9 factor into?
X minus 9. X minus 9.
X plus 3, X plus 3.
X plus 3, x minus 3. So all of our factors, our least common denominator is x plus 3 times x minus 3. So we multiply everything times x plus 3 times x minus 3, but the only thing that's actually getting multiplied is the one that's missing from the denominator, because the one that's already there is going to get canceled out. So in the first one, the x plus 3 cancels out with the x plus 3, so I'm just multiplying by what was missing from the denominator. So it's just x times x minus 3. Then that's equal to, the next one, the x minus 3's cancel, so then we have 2 times x plus 3.
You're looking. I'm not gonna lie.
So then the next one has both x plus 3 and x minus 3 in the denominator, so then we still have that minus 1. Now let's simplify. We're going to distribute our x and distribute the 2. So x squared minus 3x is equal to 2x plus 6 minus 1. We want to combine our like terms and move everything to one side because we're going to have to factor here since we have an x squared and an x. So I'm going to subtract 2x to move it to the other side, and then this would be 5. So I also want to subtract 5 and move it to the other side. So x squared minus 5x minus 5. Does this factor? No. So what do we have to do if it doesn't factor? Quadratic. So we have our a, b, and c. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. You have to know the quadratic formula for tomorrow. So make sure you know that. So negative 5 would turn into positive 5 plus or minus the square root of 25 minus 4 times 1 times negative 5 over 2 times 1. So we got 5 plus or minus square root 45 over 2. Always check to see if you can simplify the radical. What are 2 factors of 45?
How'd you 45?
25 plus 20. 4 times 5 is 20. 9 and 5. 2 factors of 9. 3 and 3. So what is going to come to the outside? 3. So we have 5 plus or minus 3. What stays on the inside? 5. So 3 square root 5 over 2. this would be our answer. Always check to see if whatever answer you get, if you plug it in the denominator, that it doesn't give you 0. So here, let's say if this factored out perfectly and we got x is equal to 3, could 3 be an answer? Why not? Because 3 minus 3 would give us 0 in the denominator. So always just check for extraneous solutions when you have these questions with fractions. You cannot have 0 in the denominator. All right, next let's do 28. We can do any one from this page. Any one that you guys want to see?
30.
30 would work. Actually, let's do 28 because it's a little bit different with factoring. We can do 32 if you want. So since we have an x squared and an x, we have to move everything to one side. So I'm going to subtract the 1. 2x squared plus x minus 1 is greater than or equal to 0. How would I factor this?
Yeah, that's what I couldn't figure out.
Multiply the first times the last. Anytime we start with a number that's not 1, you have to multiply the first times the last. So we got negative 2. What are two factors of negative 2 that add to 1? 2 and negative 1. So we get x plus 2 and x minus 1. What do we have to remember to do if we start by multiplying? Divide by the 2. So here this would be x plus 1. And then this one would be 2x minus 1. So when we solve, we get x is equal to negative 1 and x is equal to 1/2. So because this is an inequality, we have to see if it falls in between these two numbers or outside of these two numbers. So I'm going to put them on a number line. Negative 1 is smaller, so that's going to go to the left. What's a number in between negative 1 and 1/2? 0. So let's plug in 0 to test and see if we're going to shade in between or outside. So when we plug in 0 to the original equation, we get 2 times 0 squared plus 0 is greater than or equal to 1. So 0 is greater than or equal to 1. Is this true? 0 greater than 1. No, not true. So we're not shading in between. That means we're going to shade on the outside. So writing our answer in interval notation, what would our interval start with if it goes to the left? Negative infinity, 2. Negative 1. And then?
Negative 1/2 to positive infinity.
1/2 to positive infinity. And these should have brackets because it's greater than or equal to, so they're closed circles. So we should put brackets there. Let's do 30. What should I do first for 30? Distribute. So x squared is greater than 3x plus 18. And we want to move everything to one side because we're going to have to factor. Let's move it to the left to keep that x squared positive. So x squared minus 3x minus 18 is greater than 0. What are two factors of negative 18 that add to negative 3?
6 and something. 6 and...
Negative 3 and 6.
Negative 6 and positive 3. So x minus 6 and x plus 3 is greater than 0. So what does x equal? 6 and negative 3. So we're going to put those on our number line. So we have negative 3 and positive 6. What's the number in between negative 3 and 6? 0. So let's plug in 0 to test and see. So we have 0 squared is greater than 3 times 0 plus 6.
This is like
That was actually like a crazy test there.
It definitely can. 0 plus 6 is 6, and 3 times 6 is 18. Is 0 greater than 18?
No.
No. So we're not shading in between, so that means we shade on the outside. Here, since it's just a greater than, we put open circles. So how would we write our interval notation for this one?
This is what I'm getting confused in.
Negative infinity to -3 and 6 to infinity. If it's greater than or equal to or less than or equal to, the numbers would have brackets. If it's just greater than or less than, then the numbers are going to have parentheses. All right, let's do 33. Use the quadratic formula to solve. So negative b plus or minus the square root of b squared minus 4ac over 2a. So here we have our a, b, and c. For 32, what would I have to do first before I plug it into the quadratic formula? Move the 9. So it has to be equal to 0 before you use the quadratic formula to solve. 33, we're already good, so let's plug it in. So negative 12 plus or minus the square root of 12 squared minus 4 times 6 times 7 over 2 times 6. So negative 12 plus or minus the square root of 144 minus, this would be 24 times 7, 168. Over 12. So negative 12 plus or minus, what is 144 minus 168? Negative 24 over 12. Let's simplify our radical. So square root negative 24. What are two factors of 24? 2 and 12 works. You could say 4 and 6. That would work too. 12 would be 3 and 4. And 4 is 2, 2. So we have a pair of 2's that are going to come out. So negative 12 plus or minus 2. I had a negative on the inside. So what does the negative under radical turn into? I. So 2i. What stays on the inside? 6. So 2i squared 6 over 12. Can we simplify this? Yes. If all three of our whole numbers are divisible by the same thing, you can simplify. But all three whole numbers have to. 3 of them, not just the first 2. So all 3 of them are divisible by 2. So this would be negative 6 plus or minus I square root 6 over 6. All right, next, we want to solve by factoring. Let's look at 36. What should I do first for 36? Take out the GCF. If we didn't have a GCF, we'd have to multiply the first times last. So x squared plus 5x plus 6 is equal to 0. What are two factors of 6 that add to 5? 2 and 3. So x plus 3 and x plus 2. So what does x equal? Negative 2 and negative 3. All right, next section, find the domain of each function. There's 3 things we have to look for. Our domain would be negative infinity to positive infinity unless we have a square root, then we set whatever's under the square root greater than or equal to 0, because we can't have negatives under the square root. If we have a fraction, we set whatever's in the denominator of our fraction not equal to 0. And if we have a square root in our fraction, we just set whatever's under the square root greater than 0, because it can't be equal to. Perfect. First one doesn't have any of those, so it'd be negative infinity to positive infinity. Which one of the next ones do you want to do? Let's do 40. So 40, we have a square root under our fraction, so we just set whatever's under the radical greater than 0, because if it's in the denominator, it cannot be equal to 0. So 2x squared minus 5x minus 4 is greater than 0. Now we have to solve, so let's see if we can factor this. How would we factor? First times last. So we get negative 8. Do we have two factors of negative 8 that add to negative 5?
No.
No. So what do we have to do? Quadratic formula. So this would be our A, B, and C. We have negative b, so that turns into positive 5, plus or minus the square root of b squared, minus 4 times 2 times negative 4, over 2 times 2. So 5 plus or minus the square root of, this would be 25, 8 times 4 be 32. And 25 plus 32 is 57 over 4. So this would be greater than 0. So we technically have two answers here. We have 5 minus square root 57 over 4 and 5 plus square root 57 over 4. So since it's greater than 0, we have to write our inequality, or since we have an inequality, we have to write it in interval notation. So we have to figure out if we're shading in between or outside. We can plug in 0 to test and see if that works. So we're plugging it into here. So this would be negative 4 is greater than 0. Is this true? No. So that means we're shading on the outside. So we would say negative infinity to 5 minus square root 57 over 4. And 5 plus square root 57 over 4 to infinity. So what does multiplying by 1/4 on the outside do to our graph? Vertical shrink, awesome. What about multiplying by a negative on the inside? Reflection on the y. What about multiplying by 3 on the inside? Horizontal shrink by 1/3. Subtracting 7 on the inside? Right 7. And then subtracting 6 on the outside? Down 6. Awesome. All right, next ones, we want to find the slopes between the given points. The slope formula is y2 minus y1 over x2 minus x1. So I'm going to do 45. So you have x1, y1, x2, y2. Just be careful with plugging it in. Negative 9 minus 11 over 4 minus negative 3. So we get negative 20 over 7. For the next ones, we have to find the slope from each function. So to find the slope, we want to put it into y equals mx plus b form. Well, in 47, I don't have a y. So let's just make it x equals. So what would I need to do? Let's combine our like terms. So we're going to subtract 3x. So we get 3x is equal to 2. Divide by 3. So x is equal to 2 over 3. What type of line is an x equals graph? So if it's x equals, it has to touch our x-axis. So that would be a vertical line. Touches the x-axis. What is the slope of a vertical line?
This isn't my game.
Gotta know this for tomorrow.
Is it whatever number that touches?
Undefined. We have no slope here, it'd be undefined.
Oh, that's pretty obvious. I'm really dumb.
Let's talk about slopes for a second. So we have 4 different options for slopes. If I have a horizontal line, what is my slope here? Slope would be 0. Perfect. If I have a line that is increasing like this, what would our slope be? Positive or negative? Positive. What about if we have a line that is decreasing? Negative. So make sure you know these 4 for tomorrow. 48. 48, we want it to be y equals, because we need it to be y equals mx plus b. So let's move everything else except the y to the other side. So 9y is equal to negative 8x plus 3. We're going to divide by 9. So y is equal to negative 8 over 9x plus 1/3. What would our slope be here?
Negative.
Negative 8 over 9. So it's just whatever's in front of the x. Once you make it y equals mx plus b, whatever's in front of the x as your slope. All right, 49, we want to find the midpoint from the set of ordered pairs. So our midpoint formula is the average of the x's, so x1 plus x2 over 2, and the average of the y's, y1 plus y2 over 2. So I have x1, y1, x2, y2. So 4 plus 2 over 2, negative 6 plus 13 over 2. So we get 6 over 2, which would be 3. And this would be 7 over 2, which is just 7 over 2. Next, to find the distance formula, or our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I have x1, y1, x2, y2. So negative 6 minus 12 squared plus 4 minus negative 8 squared. So this would be negative 18 squared plus 12 squared. What is negative 18 squared? Plus 144. So this would be 468. We could simplify this. Square root 468. 4 goes into this. 117 times. 3 goes into 117. How many times? 39. And 3 goes into 39. 13. And 4 has 2 and 2. So 2 and 3 are going to come to the outside, and 13 stays on the inside. So this would be 6 square root 13.
I really thought maybe calculate.
Next, we're going to find the x and y intercepts. So to find the x-intercept, we plug in 0 for y. To find the y-intercept, we plug in 0 for x. So it's always the opposite one. So let's start by finding our x-intercept. So we want to plug in 0 into the y. So we have 4x plus 5 times 0 is equal to 16. 4x is equal to 16 because 5 times 0 would just be 0. Divide by 4. So x is equal to 4. How do I write that as an x-intercept, a point? 4, 0. We found the x, so that goes into the x spot. Now for our y-intercept, we're plugging in 0 into x. So we have 4 times 0 plus 5y is equal to 16. So 4 times 0 is just 0. 5y is equal to 16. Divide by 5. Y is equal to 16 over 5. How would I write that as a point? 0, 16 over 5. Awesome. So those would be our two answers. Next, we're going to write the equation of a line parallel to the given function that goes through the given point. So parallel, what do we know about the slopes?
Same.
They're the same. So first I want to find the slope. I need it to be y equals mx plus b to figure out what our slope is. So I'm going to divide everything here by 3. So y is equal to 2x plus 3. So what's our slope here? 2. So the slope of the new line is also 2. So I only care about the slope from this line. After that, I can just get rid of it. We're not using anything else from the line anymore. We're using our point. Now I have the point and the slope. So I need point slope form. So y minus y1 is equal to m times x minus x1. So I have my slope. My point here is x1 and y1. So y minus 3 is equal to 2 times x minus negative 2, which would become plus 2. All right, the next one, kind of the same idea. We want to write the equation of a line perpendicular. So what do we know about the slope when it's perpendicular? Opposite, what? Reciprocals. Meaning that it's the opposite sign and we have to flip the number. So what's my slope in the line for 57? It is 3 over 4, but our slope of the new line would be what? Negative 4 over 3. So now we can ignore the line. We're just going to use the point and our new slope. So we have y minus y1 is equal to m, so negative 4 over 3, times x minus x1, which is 9. All right, 59, we want to use the rational root theorem to find the zeros. So a rational root theorem is p over q. If you can't factor it, if you have too many terms to factor, you want to use p over q. So factors of the last over factors of the first. So what are factors of 12? 4, 3, 1, 2, 6, and 12. And it's the positive and negatives of these numbers. So what do you want to try first? So we put our coefficients in the box. Make sure you're not missing anything. If you skipped a variable, make sure you put a 0 in that spot. But we have our x to the 4th power, x to the 3rd power, x squared, x, and our constant. So we're good. Let's try 2. So we drop down the 1. Tablet says let's try 2 first. So we multiply. We get 0, 0, negative 7. This would be negative 14, negative 6, negative 12. Does 2 work? Yes. So x is equal to 2 is one of our answers. Not always. Now we want to use our answers that we just found and do it again. So I'm going to drop down the 1. What do you want to try next? Sure, we can try 3. So 3, 9, this would be 2, 6. Does 3 work? Yes.
Actually, like 100% with this prediction.
Our question started with x to the 4th power. Then we had x to the 3rd power. Now we're at x squared. Once you get to x squared, just factor it from here. So we have x squared plus 3x plus 2. What are 2 factors of 2 that add to 3? 2, and 1. So x plus 2 and x plus 1. So what else does x equal? Negative 2 and negative 1. So these would be our 4 answers. All right, for 62 through 64, it says use long division to divide. But if this was a multiple choice question or even a free response question on a final where I'm not going to look at your work, what else could you do?
What?
You could do synthetic division. Okay, so you can pick whatever way you like to do better. Do you want to practice long division here?
Do we need to have long division? We can always use synthetic.
If it is an x, like x plus 3 or x minus whatever, a number, you can use synthetic division. If it was x squared, you would have to use long division. So you want to change the sign. So positive 3 is going to go on the outside. Then you have 1, negative 5, and 2. Drop down the 1, negative 2. This would be negative 6 and negative 4. So if I started with x squared, what's my answer going to start with? X minus 2, and the last number is our remainder. So x minus 2, remainder, negative 4. But you can write your remainder like that. If it was a multiple choice question, you might also see it like minus 4 over x minus 3. Now if you had a question like 64, you could also do synthetic division here. It's just going to be a little bit trickier because what's going to go outside? So just like when we changed the sign, we set it equal to 0, so this would be negative 1/2. So you just kind of have to solve. Again, you could use long division here if you wanted to, but we can practice synthetic division with a fraction. What's negative 1/2 times 4? Negative 2. This would be 0, 0, negative 2 times negative 1/2. Positive 1. And then negative 3 plus 1 would be negative 2. So here, this would be x squared. 0x minus 2, remainder, negative 2. So 4x squared minus 2, remainder, negative 2. Let's look at 69. What should I do first for 69? Take out the GCF. Awesome. Our GCF is x squared. So we take out an x squared, we're left with x to the third power plus x squared minus 8x minus 12. Now we still have to solve the part inside, and it doesn't factor, so we have to use p over q. So factors of 12 would be plus or minus 1, 2, 3, 4, 6, and 12. Inside the box, we have 1, 1, negative 8, and negative 12. What do you want to try first?
2.
2. So this would be 2, 3, 6, negative 2 doesn't work.
Wow. Has to be 1 then.
I don't think it'll be 1 either. It might be. 1, 2, 2, negative 6 doesn't work.
Alright, it's 4. I'm kidding, it's 3. It's 3.
Okay, let's try 3. 3, 4, 12. This would be 4, 12, 0. Awesome. 3 works. So x is equal to 3. From here, we can just factor it. This would be x squared plus 4x plus 4. What are 2 factors of 4 that add to 4? 2 and 2. So this would be x plus 2 and x plus 2. So what does x equal? Negative 2 and negative 2. Now here, I had x to the 5th power to start with, so I'm missing 2 answers. What else are my answers? What am I missing?
The 3. Oh, no.
0 and 0. We took out the x squared, so we still have to set that equal to 0. So x squared means that I have 2 zeros also. So now let's talk about our multiplicity. At 3, so x is equal to 3, what's our multiplicity? Our multiplicity would be 1, which would be odd. at x is equal to -2, what's our multiplicity? 2, which is even. And at x is equal to 0, our multiplicity is 2, which is also even. All right, for 70 and 71, let's do 71. What's going to go outside the box here? -2. When it says like f of the number, q of the number, you don't change it. Only if it was like x plus 2, that's when you would change it. So here, -2 is going to go on the outside. Inside, I'm missing a couple variables. What am I missing? X to the third power, what else? And x. So I have 4, 3, 0, -6, 0, and 4. We're going to drop down the 4. We get -8, -5, 10, -20, -26, 54, -108, and then -104. So Q of -2 would be -104. 72 and 73, use the remainder theorem to tell if the binomial is a factor of the polynomial. We use our remainder theorem, which is synthetic division. And we want our remainder to be 0 if it is a factor. So let's do 72. Always when you plug in your numbers, make sure you're not missing any terms. We have 1, 4, -7, -23, 23, and 12. Outside the box, we have -4. So -4, this would be 0, 0, -7, this would be +28, so 5, -20, 3, -12, and 0. So is x plus 4 a factor? Yes. When your remainder is 0, that means that it is a factor. All right, 74 and 75, find the vertex. So to find the vertex, we use -b over 2a. To find the first one, how can I find the second number in my vertex? What do? Plug it in. So plug it back in. So here, this would be negative, we have a, b, and c, -4 over 2 times 3. So -4 over 6, which would be -2 over 3. So that's going to be the first number in our vertex. If this was a multiple choice question, look at your answer choices from here. See which ones match. Maybe there's only one answer choice that has this as the x in the vertex or the h in the vertex. So then you could be done. You don't even have to plug it back in. But let's plug it in to find the y. So we have 3 times -2 over 3 squared plus 4 times -2 over 3 minus 2. So we have to square it first. When we square it, we square the top and the bottom, so 4 over 9. We simplify this, it would be 4 over 3 plus -8 over 3 minus 2, which we want to have a common denominator, so we could change it to be 6 over 3. So let's add all of our numerators up together. 4 minus 8 is -4, minus 6 would be -10 over 3. All right, For the next ones, let's look at 78. Here we're subtracting f minus g, so 3x squared plus 1. We're subtracting the whole function g, so minus 4x minus 2. When we simplify this, don't forget to distribute the negative. That was like the number one mistake that people made on this question on the last test, or test 2. So 3x squared plus 1 minus 4x plus 2. So 3x squared minus 4x plus 3. Let's do 80 right below it also. We have f plus h of 2. So I'm going to plug 2 into my f function. So we have 3 times 2 squared plus 1. And I want to plug in 2 into my h function. And then add those two together. So I'm going to find what each one of them are separately and then just add it together. So 2 squared plus 1 over 2 minus 3. 2 squared is 4 times 3 would be 12 plus 1 is 13. Plus, here we have 5 over negative 1, which would be negative 5. And 13 plus negative 5 is 8. So just find what each one is separate and add them together.
Can you do the one that we just did?
Right, let's do 82. So we're going to find f of g. So you always take the second one, and that is going to go inside the first one. So we're going to take our function g and plug it into x in the f function. So we have 3 times, now I'm plugging in the whole function g into that x spot. So 4x minus 2 squared plus 1. Bless you. When we simplify this, we have 4x minus 2 squared, so we're going to have to FOIL that. So this would be 16x squared minus 16x plus 4. Then we distribute the 3. So 48x squared minus 48x plus 12 plus 1. So 48x squared minus 48x plus 13. We'll set up both of them. For 84, remember we changed the sign, so it'll be x plus 2, x minus 3. When we have a fraction, the denominator goes in front of the x. So 2x plus 1. From here, I would FOIL the first 2 together, FOIL the second 2 together, and then multiply those 2 answers together. Let's set up 85. So we have x minus 1. When it's just x is equal to 0, it's just an x, which I'll write in the front because that'll be the easiest to distribute. Then x plus 6 and x minus 9. So I'm going to start by FOILing 2 of them out together. I'm just going to leave that x out front, save it for last. So x squared plus 6x minus x minus 6. X squared plus 5x minus 6. And then I'm going to multiply that times x minus 9. So we get x to the third power minus 9x squared plus 5x squared minus 45x minus 6x plus 54. Combine like terms. X cubed minus 4x squared minus 51x plus 54. And then lastly, I'm going to distribute the x to everything. So x to the fourth power minus 4x cubed minus 51x squared plus 54x.